Morning ISC. This is Adarsh Pandey on behalf of my team Solar Quad of Department of Physics, Institute of Science, Banaras Hindu University. We are delighted to present our model for your Pravega, an annual fest at ISC Bangalore. Our topic for a science exhibition is hydrogen production by solar hydrogen panel. This is a bit futuristic approach we are taking over, and uh, before I'll brief you all the components of our model, I'll let you know with the introduction of our solar hydrogen panel. Solar hydrogen panel, our component. Solar hydrogen panel, for an instant intro, it's a device which uses sunlight and water to produce hydrogen directly. It works on the concept of a solar panel, but instead of generating electricity, it produces hydrogen gas. The panel contains a photocatalyst layer that absorbs sunlight. When light hits the catalyst, it splits water and hydrogen and oxygen. The method does not require electricity. That's the main point. Now moving towards working principle, I'll be briefing you all we all are aware, and for your better understanding, we'll attach this PDF for your convenience. Uh, Working principle, basically first we'll go on light absorption, secondly charge separation and transport, then electrochemical reactions and electrodes which will be mentioned. It's a fuel cell, I'll come on that too. Electric chemical cell, gas collection, and finally hydrogen storage and uses. In this project, we are only focused to hydrogen production and not be discussing any kind of storage and uses tendencies. Now for this process, above the setup, we are using photoelectrochemical cell, which actually based off of semiconductor materials, and the basic electronics works. What happens exactly when the sunlight hits the semiconductor? Electron from the lower energy level goes to higher energy level and energy releases. And from that, apart from the very similar to the conventional methods we use for the electricity, here we are using that same energy for hydrogen production, basically water splitting for hydrogen and oxygen. In this project, we aim to produce hydrogen by using solar hydrogen panel. In this, we can, by using sunlight and water, we produce hydrogen gas directly. For our panel, its setup is like, instead of using electricity, we are using sunlight. It's far different from the conventional methods. Our panel uses photocatalyst layer, and that absorbs sunlight and it splits water into its components, hydrogen and water. Now, let's commence the discussion of the setup which we are using inside the photoelectrochemical cell. Here we have setup of thin films integrated next to next. In between, let's commence with melamine sponge. In between, we are using as a photon exchange membrane. Melamine sponge is somehow it's made up of it's a sponge, it's a foam like material which is made up of formaldehyde, melamine, sodium. Here we are by this we are melamine, this is melamine formaldehyde foam. On heating we get nitrogen doped carbon foam. On heating, as obvious, we have the increased contents of nitrogen here, so it's nitrogen doped carbon foam. For we can also have a look on its chemical structure, which is this. It's electrically conductive and it provides the surface for all the electrochemical reactions. And melamine is the base material. Melamine sponge is we are using here. It's different from the conventional methods we do follow right now in laboratories for electrolysis. This is a material which absorbs all the water contents from the moisture and split over its surface and provides electrical transports, electrical conductivity to the material. Next to the melamine sponge, we have anode catalytic layer and cathode catalytic layer. These catalytic layers, if I could, these catalytic layers is a very thin coating of photocatalyst material applied to the surface of melamine sponge, and which helps to sunlight and water to react and produce hydrogen efficiently. Cathode catalytic layers, here on cathode catalytic layer, oxygen evolution reaction occurs, and at cathode catalytic layer, hydrogen evolution reaction occurs. Here, for next to that, if you could, materials made up of cathode catalytic and these, next to the catalytic layers, we have gas diffusion layer. We could also discuss, we have the anode catalytic layer, which is made up of iridium oxide, and cathode catalytic layer, which is made up of platinum black. We are using here for obvious cost effective reasons, and we are using a thin film, this thin film of iridium oxide and thin film of platinum black. Next to catalytic layers, we have gas diffusion layer. Gas diffusion layer provides a surface area for the reactions, and it provides an integrity next to the catalytic layers, which also allows them to react and prevents gases to intermixes from electron, proton and liquids. Lastly, in the setup, we have bipolar plates, which provides the integrity to the whole system. Bipolar plates is a very most critical structure, and it's a functional component of photon exchange membrane. Fuel cell, as it's very likely the fuel cell, where it does prevents and managing the transport of heat, electricity, gases and liquids. Here it does for hydrogen, electron, proton and water, oxygen. And this is the whole component. This is the discuss. Here we have firstly melamine sponge, then catalytic layers, GDL, gaskets, bipolar plates. This whole system provides the basket with the procedures. From here it begins, and in addition to that, we have discussed. Later, in addition to that, I'll also like to discuss some of the major components we have here about the efficiency of each material. And this PEM, photon exchange membrane, and catalytic gaskets, BPP, for making it cost effective, we have used thin films of each layer of the nanoparticles. Lastly, in the setup, we have bipolar plates. Bipolar plates is made up of titanium, and here in the whole setup, it provides integrity to the whole structure. It's the last bound plates, and it provides integrity to the whole system. And we have this all working procedures in this setup. This is an idea for the futuristic approaches for our energy system. This is a futuristic idea which can solve the energy crisis of globe. Hydrogen is a very versatile and engaging topic for the globe right now, and its production, storage and various discussion. This is topic which is still in research, and as we know, for here the problem with the hydrogen is feasibility. Here we have certain parameters and certain works to resolve these feasibility and efficiencies. I'll discuss this further. Before I'll let you all know with the applications of hydrogen gases, so this panel, it's various including the industrial productions to the households to the fuel transports in the off-grid panels. It's a various and residential to all their various uses. The setup, why do we choose? It's a futuristic and it in conventional right now in labs, what the electrolysis or by xenon method, the water splitting we does, it produces somehow 9.8% efficiency currently, but uh, in a system, in labs, and somehow it also up to 13.8% noted till yet. But this setup could provide you efficiency up to 17.8%, and also by this you can also in a laboratories also till 19%. This setup, the basic criteria for this setup to work is the moisture in the air. In India, it's very much functional, it's very much futuristic, because if you could talk, there's a very much less moisture in air. I would say the most off-grid region, arid region, is Rajasthan. If you could ever see in Rajasthan in June, the most high peak of summers, in nights the moisture is somehow around 28 to 30%. This is the moisture noted in Rajasthan in peak summer June in nights, and this is a very lot of average, and this setup requires only 20% moisture to work. As lastly, our model is on solar hydrogen panel, which is a bit futuristic topic. It's in research phase. Hydrogen is, as we all know, it's a very engaging topic throughout the globe. We have discussed the topic, applications we all know, and we have discussed the applications. In addition to that, we have simulations, PPTs. It's a bit boring. I'll be reading out here. I'll will be attaching this to the our video, so it will be more convenient for you. It will be for better understanding. Now, I'll be introducing you to my teammates of Solar Quad, who have devoted their nights and days for this project, for this idea. Firstly, Ritik Jangid, who has been through all the technicalities, and Anuj Kumar Singh, who has been through all the chemistry of chemical composition, structures of all the materials involved. Lastly, my friend Hariom Kumar, he has been through the very comments from the very basic idea to lastly the project has been now. This is a futuristic idea, a bit interesting topic for us. We are privileged to work for you on this idea. We are privileged for the opportunities I see, and lastly, very thankful, and in it, happy new year in advance, and great wishes for your Pravega. Thank you, IC. Thank you for the opportunity. Thank you.